Welcome to our YouTube channel. Now, on physics, today we'll be working on dimensions. When you take a look at this dimensional question from JAMB 2008, you observe that as when you talk about dimension, most of the students normally run away from it, or basically, they run away from the basics of physics, the beginnings of physics, those basics of physics. Because when you talk about physics, you talk about matter. And when you talk about matter, you talk about quantities of matter. And also when you talk about quantities of matter, you talk about the fundamental quantities and the derived quantities. And when you take a look at this is a dimensions on those quantities. In physics, we have dimensions as the first letter of what? The fundamental quantities. The first letter in capital letter of the fundamental quantities, which we have as the main, as the mass. The mass to be what? M. And the length to be L. And what? Time to be what? C. These are the first letters of the fundamental quantities. Now, when you take a look at this question, you observe that the question says the dimension of electromotive force. These are the options. Now, I want to ask you, what is electromotive force? Because this is the first question you must ask to yourself. What is electromotive force? Now, you must recall that electromotive force, which we know as the what? The EMF V, is the work done in moving what? A unit what? Charge around a circuit. You can call it the driving force of what? Charge. And when you talk about electrical charge, the quantity of charge, you also talk about what? The presence of current. Because you cannot talk about electricity without talking about current. Now, the electromotive force as the work done in driving a unit what? Quantity of charge. If V is equal to work done over charge, you must recall that work done, the first statement is that work done is what? Force times distance. And charge is also what? Current times what? Time. This is the first thing you must do. Force is mass times acceleration. Let me have it as A. But when you come to acceleration is meter per second square. You are aware of this. And if acceleration is meter per second square, now, can we apply the dimensions using the first letter of this? But before I do so, remember that this is what I want. I will start from the down and come up. That is the pattern. And the pattern here is that acceleration is meter in dimension is what? Length. And when you talk about length, the unit of meter is length. And when you talk about length, it is what? Capital L. When you talk about time, S. Time here, S is T in dimension. To have what? Over. This is over. T2. So that I will have, when this T raised to power 2 comes up, I will have length and what? Times time, T, raised to power minus what? 2. Because it has come up at the numerator. Now, since I've gotten this as the what? My dimension of acceleration, I will have my force to be equal to mass. Mass here, the dimension of mass is M. And the dimension of acceleration is L2T raised to power minus 2 as the dimension of force. You get what I mean? When you have this as what? Mass times the dimension of acceleration, I will have this in multiplication. Now, I will love and like you to subscribe to our YouTube channel, share and like to this video. Now, let's go back. From having force to be this, we'll now go back again to the work done, where we say that work done is force times what? Distance. Therefore, my work done will now be, what is force? What is distance? The unit of distance is length, and the dimension of distance, length, is L. But already I have my force to be M LT in the power of what? 2 minus 2 times L, which is the dimension of distance. And when you multiply these two, I will still have my work done to be mass, which is M, my distance, which is L, my time, which is T in raised to power what? Minus 2. And when length times length, I will have length to the power of 2. Because when like base are multiplying, you add their powers. 1 plus 1 gives 2. Now, since we have gotten the dimension of work done, can we go to the electromotive force? From the question, electromotive force is what we are demanding for. And this is the work done. Charge is current times time. And I said, current is a fundamental quantity. Therefore, I will have my potential, the electromotive force, to be equal to work done is still my M L to the power of 2 times to the raised to power of minus 2 all over. Current, charge is current. Time is T. Now, the EMF will now give you what? M L squared T raised to power minus 2. When time T comes up to the numerator, it will now be T minus 1 because it already has a power of 1. When it comes up, it will change to negative. The same thing is applicable to current. Current will still be what? Minus 1. So that I will have my EMF to be the mass M L squared. We have time to be minus 2 minus 1 will give me minus 3. And the current remains minus 1. And this is the dimension of the electromotive force. And from that option, from these options, that we have as the answer is what? Option A, which is the answer. Thank you for watching.